All right, so today I'll be going over Leetcode 283, move zeros. And just real quick, I got this solution from a YouTube video and I'll be linking that. And this is just me going over my explanation. And originally I thought this problem, as it said, was an easy problem. I do think the solution's easy, but it's like you have to get into the mindset of the problem, which is the same for any problem. But I feel like with this problem, the specific things you want to look for, which would kind of indicate what the solution would be. And then from there, it's easy. But if you kind of don't have familiarity with these types of problems, then it's a little hard like it was for me. So given the integer array nums, move all zeros to the end of it while maintaining the relative order of non-zero elements. Note that you must do this in place without making a copy of the array. Now, this is very important, making sure that you do everything in place. And that's another reason as to why maybe the solution might come to mind. So as you can see, we have our input 0, 1, 0, 3, 12, and our solution is 1, 3, 12, 0, 0. As you can see, all we do is just move these two zeros to the end. And when we have a single zero, all we do is return 0. Now, I guess I want to talk about some of the things I kind of learned to look for. And I guess the biggest thing is the fact that you have to do this in place, and the fact that you're sorting your numbers due to a certain factor. And that factor is, hey, if it's 0, we want to move it to the end. If it's a different number, we want to move it to the beginning. And something I noted from the video is that we just want to think of moving every non-zero number to the beginning instead of thinking, let's move all zeros to the end. That's originally what I thought and the solution I got lost in. And so when we're thinking of moving numbers with relevance to a certain factor, that's a lot like quicksort or the partition function algorithm. So in that, we're kind of have a partition point, and whether a number is less or greater, we move it to its respective side. And that's almost what we're doing here. And that's kind of what we're referencing when we do this. So now on with the code, we say, okay, left is equal to 0. So think of this like maybe if it was C, it would be like a left pointer, but all it is just left is equal to 0. For R in range length nums, if the nums at R, as in if it's a non-zero number, so if we come across a 1, 2, 3, 4, whatever, then we say nums at L and nums at R, they just swap. And then we increase where the left side goes to, and then we return nums. And now to visualize this a little bit, let's go and let's just write down real quickly our input array. 1, 0, 3, 12. And then let's just try to think about this real quick. So first our L is going to be at 0 and our R is also going to be at 0. So then we say, okay, for R in range length nums, if nums at R, then if nums at R, which it is not, so then we go ahead again, and then our R continues up. Oh, our R continues up. So we put R like right here. And then we say, okay, if nums at R, which it's a non-zero number, then we just swap these two values. So let's swap this real quick. Let's put 1 right here, put a 0 right here. And then we say that L plus equals 1. So our L is going to move. And let's just put that like right under. Close enough. And then, okay, so then we go to another iteration and we know our R is going to move up. And then we say, okay, well, is this a non-zero number? No, it's not. So let's move our R up again. So we say, hey, is this a non-zero number? Yes, it is. So then let's swap it with where L is. So we put a 3 here. We put a 0 right over here. And our L continues up. And the R would also increase. Oh, R would also increase. And we say, hey, is this a non-zero number? Yes, it is. So let's swap it with where R is. I mean, with what L is. So we say 13. And we say 0. So now kind of think about this just relatively, just like without looking too much into the code. Basically, all we're doing is that we're holding the first 0 index that we come across, and then we're moving our R beyond that. So whatever number that we come across that isn't a 0, that first number will get swapped. So that's the way that we're keeping the order. Actually, this is supposed to be a 12 instead of a 13. Yeah, 1, 3, 12. I was like, what? Okay, but yeah, and that's essentially what you're doing. That's like what I wrote down there if you want to read that comment. But I hope that made sense, and that's just me kind of just going through my thought process and how I wish to approach this. If I were to come across another problem like this, the things that I would look out for next time would be, okay, am I trying to do something in place? and am I moving my numbers with relativity to either a certain position or a certain number? And that should scream to me, okay, quicksort, let me do something along the lines of this. So yeah,